The Bilateria, no longer radiata with radial symmetry. These are bilaterians that have bilateral symmetry. In the Bilateria, we see the dawn of cephalization, or the first organisms that truly have heads. A head being a collection of sensory organs, just like your head can hear and smell and see and taste, and also has other sensory capabilities. If you touch your cheek, you know your cheek is being touched. You can feel the wind blowing through your hair. Um, so cephalization is really all about the accumulation of sense organs to meet your environment. And as it happens in our case, invertebrates, it includes a brain, a very complex structure that controls the central nervous system. All right, we also, in the Bilateria, get a third germ layer in the mesoderm. So the embryo now produces mesoderm. It is triploblastic, has 3 germ layers. And because we have 3 germ layers, we can go beyond the cellular level of organization, beyond the tissue level of organization, into having organs and organ systems. Within the Bilateria, we see this evolutionary trend from having no internal body cavities to having a false coelom, or a body cavity, a fluid-filled cavity that is not completely lined with mesoderm, to having a true coelom, or being eucoelomate, and having a mesoderm-lined, fluid-filled body cavity. As it turns out, this little asterisk next to pseudocoelomate is because pseudocoelomates seem to have evolved numerous times by convergent evolution. So it's not really a clade of a monophyletic clade. It's really more of a descriptive term, or a grade of organisms. So we're going to talk about the protostome phyla first. It seems that they have evolved first. In protostome phyla, the fate of the blastopore is that it becomes the mouth. Contrast that with the deuterostomes, where the fate of the blastopore is that it becomes the anus. But in the protostome phyla, the blastopore becomes the mouth. And in the protostomes, we've got 3 taxonomic groupings. We've got the acoelomate protostomes, we've got the Lophotrochozoa, which are mostly eucoelomate, and Ecdysozoa. So non-molting and molting protostomes, as well as acoelomates. So first we're going to talk about the acoelomate phyla. We have 2 that we're really going to focus on. The first one is the Platyhelminthes, or the flatworms. Platy means flat, like a platypus. Literally means flat foot, because of its paddle-like feet for swimming. Helminthes in general means worms. If you have given your horse an anti-helminthic paste like ivermectin, it is for getting rid of worms. So Platyhelminthes. Most of the Platyhelminthes are parasitic worms. There are some that are not parasitic, not dependent upon a host to complete their life cycle, so we say that they're free-living. Typically, they have a simple gut, kind of like a jellyfish, and there are some that have no gut at all. I'll tell you how that works in a minute. In the class Turbellaria, this is where we find most of our free-living flatworms, including these flatworms. There are a lot of brightly colored flatworms in the sea, marine environments, but also we have these rather drab-looking planarians, which are also turbellarians. So the class Turbellaria have circular, longitudinal, and parenchymal muscle. Parenchymal muscle, kind of like in plants, have parenchyma. It's kind of like a space filler. So they don't have a fluid-filled cavity, and they don't have a whole lot of different types of tissues. But not having a lot of tissues means that it's not very difficult for them to regenerate themselves if they become injured. And here you can see a planarian that has regenerated in lots of different crazy ways. That's the point where it has 4 different heads. So in looking at a planarian as a representative turbellarian, we can see that it has a head. It's got these eye spots, which are sensitive to light. They're not image-forming eyes. It gives the planarian kind of a cross-eyed appearance. It also has on its head these little points on the side, which look like little teeny ears, and they're called auricles. Auricle is an auricle, and it means little ear. But these things don't hear, they don't sense sound. They're actually chemosensory, so they're more like little noses or little tongues that can receive chemical signals to direct it towards food, for example. Planarian also has, like a jellyfish, like a cnidarian, other cnidarians, a GVC, a gastrovascular cavity. And in turbellarians, this GVC is flattened. It has 3 lobes. You can see here. Here's the one lobe going towards the anterior end, and the 2 posterior lobes going into the posterior region, into the tail. And it also has something that's kind of like the manubrium in a jellyfish, but that's its pharynx, or its throat. And the throat and the mouth is pretty far back here from where we'd expect it to be. Normally think of the mouth as being in the head, but not for a turbellarian. And it can move this pharynx around to try and capture food and bring it into the GVC. And you'll notice that there's no other way for the waste to come out. This gut the GVC, food goes in, and then the waste comes right back out again through the mouth. So that's a mouth/anus, just like we saw in cnidarians. Our second class of Platyhelminthes are the Cestoda. These are the tapeworms, all of which are parasitic, and they have some characteristics that are similar to cnidarians, but not in the same way as what we see with turbellarians. So what we're going to do next is we're going to draw a tapeworm to elucidate the life cycle of tapeworms.